Hello viewers, welcome to today's video. Today I'll be showing you a few things about beams, and then we'll move straight on to columns. For beams, which we have been talking about for some time now, so I'll just note one other thing, then straight away I'll move to first uh, of many series in columns. Now, when you arrange your beams, you have to make sure you specify the way you want your beams to be, especially when it is being cantilevered. So most times you might have arrangements, especially on suspended levels or roof beams. You have arrangements like whereby you have one beam supporting another beam. Let me delete this beam so that I'll be able to illustrate what I mean exactly. Okay, so I've deleted. Now let me model another beam. So I have 230 by 300 concrete beam. Now I want to span this beam from here to this grid, and I also want to have another beam here. Now, most cases in your roof beam, or when you have a model that spans maybe like 3 or 4, 5 stories, and you have some of your floors cantilevering out, so it is from that cantilever, probably you have cantilever beams, or you have cantilever yes, cantilever slab, and your column is placed on it and it spans, to the next floor, 2 or 3 floors, or you have beam, then on the beam you now place your column. So when you enter the member the way like this, you have to tell the software. Yes, the software is intelligent, but in this case, you as the designer, you have to tell the software your idealization and what you mean. So in this case now, you have to let the software know which of the beam is carrying which. Is it this beam that is supporting this beam, or this beam 15 supporting this beam 11? So you have to tell the software. Now I'm just making this small example. In some cases you might actually have uh, many instances like that along a particular grid line. So you have to tell the software that whichever one is supporting which. So in this case now, this span is actually shorter while this one is longer. So I would prefer this this span to support this span. This is shorter and it has adjoining beam that goes into the slab. So I will have to tell the slab. You can see this uh, red arrow that is showing on those beam. So it will tell you that the beam is cantilever. That's what that arrow means. So now I want to tell the software that make this beam to have support at both ends. So which means there's a column here to support it on this end, and there will be another support here to support it on this end, which is this beam. So if it is the other way around, then I'll make this and say this beam is supported on both ends, which means that this one is carrying this one. So but in this case, this span is longer. I wouldn't want to use it to support this shorter span, so that you won't have your the movement will not be large and it will not require higher reinforcement. So I prefer this shorter span to support this. So what you will do in that case, you will click on the beam, then you right click, then you now tell the software make this beam to be supported on both ends. So once you do that, then you can see that the red arrow goes away. So the software is now seeing it as being supported on both ends. So by that, the software will calculate conveniently the bending moment. And in this case now also, just like I've explained in the past, that the software intelligently, from what the developer told us, that I don't need to define point load. But like I've showed you in my last video, that it will depend on your analysis setting. So for you, whether for you to define a point load or not, so that depends on the case you want to assume. So in this case, if I am assuming that this, because by my assumption it means that half of this beam will be acting as point load on this particular beam 15. So by that, I know that definitely if I idealize this, I will have a straight line whereby I will now have point load at the end of it. So you need to make your settings appropriately so that your model can be actually modeled appropriately, and analysis is done also appropriately, and you get a result that is as near as what you intended. So this will be my last contribution for beams. There are so many things concerning beam, just like I've shared in my previous video, with all these settings. So you have to look at it very well and make sure uh, whatever options that you pick reflect your design intention as an engineer. So I hope it helps you make a better decision. Now I want to move on to columns now. So this will be our first lesson on columns. So let me make 3D. Now this will be very, very interesting because I know a lot of people would have been having problem with what I want to show you now, but I can assure you there's no problem. There's a way to go about it. Now most times when you design your columns, and you have some cases whereby you have a cantilever coming out and you now have your columns sitting on the slab. This has given so many people problem, and in fact I know some of my senior colleagues and some elder ones in the course of my career, that they kind of condemn the software because of this, because by the time you run analysis and you get a result, and at times the reinforcement provided in some of these roof beams will be outrageous, and they will like, oh, come on, what is this software doing? I don't understand. Then some of these columns too, it will be giving them result of higher reinforcement kind of, and they will be wondering that, no, this thing is not right. Now uh, there are some groundwork ground discussions I want to point on. Okay, let me show you now. I've defined the load. Let me run analysis. Okay, I run analysis, and here's the analysis. Now I've modeled it. So just like I've modeled, then I want a column to be there because in my room there will be room space. Now this is what you get. You said the column 10 and 2 and 11, which has these three columns. These member listed above are either fully unsupported or are supported by beams and slab. Okay, so there's a problem in the model. That's what the software will tell you, but it will still run the analysis. So let's wait for it, and it will show you the results. Okay, drift. Then I click close. It will bring the analytical model. Now this is where we are going. If you click on displacement and you see the animation, now you can see that the column is dangling. So by that, it means that there is no support. So what the software will calculate for the moment, and whatever forces that is acting will be very high in this case, because it's seen it as support. So by that, I know a lot of people that condemn the software for this, even when it was in the days of Orion, and many people, because of that, they they said no, they can't use it. But why some people find a way around it, so you can see that even on this point now, the axial load is not coming. You only get the load on this top. On the bottom, you will not see any load. You can see there's no load there. Whether it is the ultimate load, you will not see anything. Now, you in that case, now what you now have is that you have very high movement in the upper part because it's dangling. So that will result in very high reinforcement in this beam, this beam, this adjoining beam, and also it will require higher reinforcement in the column. So most times it gives a ridiculous result for anybody that is using it, and they will think like, okay, no, this thing cannot be now. So eventually, at times, you even go to site and see that, is this not what they've constructed here? And this is just ordinary 225 by 225 column, and they put 60, and the thing is standing there, and the software is telling you, giving you one ridiculous result. There's a way to go about it, so I will show you that today, so that you can have rest of mind, and have confidence while you use the software for your next project. So let me click this away, and let me close this. Okay, so this is the arrangement, and I've done the analysis, and you can see the result that is bringing. Now, another thing some engineers do is that which also works anyway. They will now provide beams along the edges to support this slab, along the edge to support this, along the so that it will support this column. But aesthetically, for some architectural design, that might not just fit well into the architectural concept of the building. So, um, in any case, some people put it while they are running the analysis. Once they've done with the analysis and they are okay with the result, by the time they are exporting their model, excuse me, for detailing, they will now remove all those beams that they put there. So which also works in a way anyway. But let me save you all that stress and show you what you can actually do, which will also be helpful for you if you are going to maybe more, if you have more than 2 3 suspended floors, so that the load can accurately transfer from one column in the upper floor to the other columns, because that is how you can actually get get the best from the software, so that it can accurately do a load chase down from the subsequent floor if you have floor that is more than this. So I will show you what you need to do. So come to model now. Excuse me. What you do is you define support, and I've actually done the support definition for that. You can see support for floor columns. So this is the default support, and default support happens to be at the foundation level, which is story 00. Now, in case you want to do your own, because you will not see this, I've done this initially. You just click add, then you give a name to the support, and you can click OK, and it will go. Now, you can see the kind of restraint. There's fixed, there's pin, and there's roller. So you can actually have oh, excuse me, some restraint in different direction, and you can release some as well, just like you do moment releases in other software. So you can release some movement based on whatever your model is. But in this case, I want it fixed, which is the option I've picked, and I click OK. So like I've said, I've defined the support. So what you now do is that you now click on the member. This is the column. This column, you click on it, you right click, and you come to properties. So when you come to properties, you come to 3D. Now in the 3D, you can see that support types. So in this support type, what you need to do is just click support type for columns, which I have defined initially from defining support. So I'll click that. Now, if you update, because I've run the analysis, is asking for this. So now you can see that it's projecting my column beyond the floor slab. So why is doing that? Because it's now seeing that there's a support at that point. And initially in my model, I have defined the foundation depth in the edit story, and the foundation depth is 1 meter. So that is what the software is saying in that particular case, so that is extending its foundation depth to 1 meter. But my is not extending. So what you need to do is just define a plain definition for that. You now define that there's an offset which is 1 meter, so you update it as well, and that goes back to position where it is sitting on the slab. So once you have that, you do the same for the columns, all the columns that are sitting on the slab. So you now have 1 meter, then you have support for column, then you update it. Once you update, you click OK. Same thing in this case, you have it like this, the 3D. Yeah, you come and say support for columns, then you offset the bottom extension back to the top of the slab. Okay, so with this you can see that it's showing now that these columns are actually supported. Now, of course, they are supported on the slab, which is what the software is not saying before. So now I have defined a support, so it's now saying that that column is supported on the slab. So when I go ahead and run the analysis, every other option's been picked, and I run the analysis. I run, wait for it. I know this will solve a lot of issues for many people. So I'm glad to show you this, so that I can help you to be more confident when you model. Now this thing is out. Now let's look at the displacement first. If you click animation, you can see that your column is no more dangling like before. It's now showing that there's a support there. So which is the case. So you can thank me for this. You can see that there's a support now. The column is no more dangling. So let me go away. And by the time you have your diagram, you can see that it's now showing that there's a load that is being transferred. You can see the load that are coming now. So if I click, so you can see that it's now showing that there's a load transfer coming from the beams at the upper part. So you can see now that it's having 24, 19, and 12. So in this case, you can see that, okay, now you can now see that there's lesser movement in our beams, because it's no more dangling, because it's now resting on a support, which is the case, which is what I've idealized. So I have idealized and I have modeled my design intention in the software, and I'm getting a result for it, which is okay. So by that I'm confident. So by the time you go ahead and design, so let's take for example, let me close this, let me design the columns. Now before I design, let's look at the columns that we are talking about here. Now it's column 10, story, that will be in story 2, column 11, column 10, 11, and 12. So let's design columns, column batch, calculate. Okay, so and message. You can see that all the columns are designed. So let me see. It's showing one thing there. I know where that problem is coming from. Let me just, that will be from the setting, that will be the concrete cover for the columns. Design parameters. Okay, let me show you selection method. This. Okay, I see. Yeah, it's supposed to be 25. It's showing 250. That's why I'm seeing one maximum error warning like that. Update column concrete cover. I don't need to run analysis again. Let me design the column again. So column batch mode design, I design. So now you can see that warning has gone. So you can see that I have all my columns designed and it still falls within Y16. So let's look at that column at story 2. Sorts good bright this. So let's see now column 10, 11 and 12. You can see. Okay. Story 2 column 11, 12. Okay, let me design the celestial bar and click. Okay, so column 1 2 3 4 5 6 10. Okay, 10 is the design, 11 design, 11 design, 12 design, 12 design. Okay, fine. Okay, I think it should be designed now. Okay, you can see that I have my Y16. You can see 16. So uh that is it now. So that by the time you take on your next project, you can be confident that okay, now let me see. Let's just click and see the result. You can see interactive design. Let's see the load that is using. So you can see that the load is actually calculated. Meanwhile, if you don't define support, if you check it, you will see that what it will be giving you will be outrageous kind of in a way, and you'll be wondering, okay, what is this one saying? So in this case now, you can be confident that your design is okay. So the one that is 24 by 16, which is fine. So that is that on all these transfer. Is it transfer columns now? I don't know if that is the right name. So that is that. So I hope this helps you a lot. And before I go, once again, the software is for automation while you have to do the engineering yourself. So by the time you have the mind of doing the engineering, then you can actually probe the software and look for solution for some of the challenges that you have. Thank you for joining me in this video. I'll see you in the next video for columns as well. Thank you. Bye.